Hello everyone, we're going to move into the third section of your unit 1. So this section will be a longer section that where we're going to discuss about vectors in more details and also projectile motion by using two-dimensional vector informations. So now we here going to start with the two-dimensional motion. You remember that in earlier section we discussed about the one-dimensional motion. That means that object is moving on x direction or moving on y direction or negative y direction or negative x direction. So this is one-dimensional motion, and also we discussed about the translational motion. Still we are working with translational motion. Again, what is the translational motion means? Your object is moving without doing any rotation. Any direction object is moving without doing rotation, that is, we call it as the translational motion. But simple example, if I drop this pawn will not be dropping like translational motion. That pawn maybe do the rotation and then drop, right? So we did not include the rotation yet to any of the motion. But we're going to discuss about two-dimensional motion in here, because you remember that when we talk about the pre-pole motion, it is moving downward direction, and I said that it is a negative y direction. Because of that displacement, we're going to take it as the negative. If moving something in x direction, we're going to take it as a positive direction. If something moving in negative x direction, we call it as a negative values. So that is coming from the vectors, because the things that we discussed, displacement, velocity, and acceleration, belong to the vector quantities. Those should have a direction. That's why when it go to the negative or positive, we need to consider the direction of those physical quantities. So now we're going to do the projectile motion in here. That means, as a simple example, if I project the ball, that ball will going to do the kind of parabolic path. That means you need to discuss your motion in x direction and also in y direction. Because of that, those we call it as two-dimensional motion, but is still translational motions. Okay, so now let me share the Blackboard page and also the presentation first. So we are working with chapter 3 in your textbook, and that will be the last section of your unit 1. And under this section, we are planning to do the two-dimensional kinematics that we discussed in your earlier section. 3 kinematics equation is still going to use for constant acceleration problem, but now the problem will be two-dimensional, not one-dimensional. Okay, that's the difference. So now when you come to the two-dimensional motion, it's very important. First, we work with the vectors. That's the first couple of minutes that I'm going to discuss about the vectors. And again, this section will be a little longer because there are many things that we need to discuss, and also questions that you're going to do it on your recitation session is actually that 2 hours is not enough for us to go over all the questions. And also I am not able to do all the many questions in your concept part of the chapter, because usually your lecture will be the conceptual part for 50 minutes max. So let's see, if you are not able to do enough problems, make sure that you go to your textbook. There are many problems. You can do it, and you can try to do it yourself. If you have any questions, always reach out. Okay. And so now projectile motion. So when you throw the basketball, you know that that ball will move in 2 directions. That direction, because of that two-directional motion, we call your ball is going a path as a projectile. So now we need to discuss this motion by using kinematics equation, and also by using those equations to x direction and to y direction. To do that, we should have a background knowledge about the vectors. That's where we're going to start. Okay, so first thing is vectors will be belong to first quadrant, second quadrant, or third or fourth in your Cartesian coordinate system. Usually your x direction is right direction and y direction is north direction, and then negative x direction will be negative x direction and negative y direction. Those are where your vectors going to stay on your coordinate system. This is negative y, this is negative x, right? So now before moving into the coordinate system, let's say that you remind yourself a trigonometric function, right? So those functions are always important to analyze the vectors, right? If you don't remember, focus in here. I have everything you need to know to work with those vectors. So first thing is, if you have a rectangle, that you know that if you take the angle of this rectangle as theta in here, then you know that this distance is hypotenuse, right? And also the length closer to the angle you choose is adjacent, and the other length is the opposite. So you have three lengths. Hypotenuse is the longest one, and then closer to the angle you have adjacent, and other one is the opposite, right? So now what you know, sine of theta will be always, you can write it as opposite over hypotenuse. That's why I have y divided by r. And cosine of theta will be always adjacent over hypotenuse, x over r. And tangent theta will be always opposite over adjacent. So that will be y over x, right? So that you already know. If you don't know, try to get that idea of those angles. So in addition to that, I have a table in here that we can keep it in mind easily. So those are degrees, and second line is radians. But important thing is sine and cosine behavior. So sine of theta will be 0, cosine of 0 will be 1, right? You see that in here. So this number is exactly same as the number I have it in here. That means sine of 0 is 0, cosine of 90 is 0. And cosine of 0 is 1, but sine of 90 is 1. Right? They are always working opposite way. And in addition to that, you will see 45 degrees, they are the same, right? And again, sine of 30 degrees is half, but cosine of 60 are matched with sine of 30. And sine of 60 match with the cosine of 30, right? So that means you need to remember only a couple of things, right? In addition to that, you can always remember to get your sine curve and cosine curve in the plot as angle theta. If I have, we'll say I have 90 degrees here, 180 degrees here, and keep going like that, right? So now sine of theta is 0, but when it go to the 90 degrees, it will be 1 and 0, and again 1 and 0, right? That means your curve of sine will go like this. As a sinusoidal curve, right? So now cosine of theta angle do the difference. So cosine of theta angle will be at 0 degrees, it is 1, but at 90 degrees, it is 0, and then 1, and then 0, and then 1 in here, right? So now that's how the cosine function will work. That means it's going like this. So that's why cosine of 0, 1, but sine of 0 is 0. They will going exactly 1 separation at that degrees. So now because of that, they will be the same. So now you can see in 45 degrees, they are going to make the same number. That's why at 45 degrees, they have the same. Okay. Okay, so now let's move into the little more about the vectors. So we discussed about the vectors. So far, displacement, velocity, and accelerations are vectors, right? Vectors should have direction and magnitude both. That means there are some quantities you cannot describe only by using magnitude. Simple example, you're going to apply 5 newtons. So as soon as I heard that words, I need to ask which direction did you apply the force? That kind of quantities, we call it as the vectors, should have a direction and magnitude both. So that will represent by using the arrow line, this length of the line, we call it as the magnitude, this call it as the direction. This is head or the tip. And this is tail or the, say, tail of the vector, tail and head, right? So now there are scalar quantities, as you know, temperature, mass, speed, distance, those all are scalar quantities that you do not need to express the directions. Okay, simple example is your odometer in your car will read the basically distance. That does not know about the displacement. Okay, so now notation of the vectors, different textbook, different people use different notations to separate it from the magnitude. So usually if I have a vector velocity, the magnitude, I use just a V symbol. For the vector, I may use the bold letter V, or I may say velocity vector. So to understand, these two are different, right? So similar to that, some people use the V with the arrowhead on the top. Some people use V with just a line to represent the vector. These all are notation of vectors, right? And also some people use two places and define the vector A to B. That's another way of expressing the vectors by using notations. Okay. Okay, so now we're going to go to the addition of vectors. In your class, our main focus is adding and subtracting vectors, but vector has different algebra, multiplication and divisions that we are not going to talk in your class. Okay, so vector additions. So we're going to discuss two methods. One is the graphical method. In words, you see that graphical means basically I need drawing tools to do that method. But we're going to do the cartoon in here in the experiment laboratory. You're going to experience with exactly drawing by using graphical methods, by using ruler and the protractor. But here we're just going to understand just cartoon, that how we can do the graphical method. So now simple example that I can say, okay, I have two vectors. One, I decide to go to the right. This direction is my right, although you see as left. So I have a vector that I'm planning to go to the right direction, 8 kilometers. And then I decide I need to go another 6, the same direction. Now I have two vectors, both are same direction. I will be able to add these two, 8 plus 6. That means I have 14 kilometers to the right. Okay, there is no frictions. So, but we'll say I forget something, I need to go back. And then after I travel 8 kilometers, I decide to go back 6 kilometers. When I go back 6 kilometers, I have a very small separation, 8 and 6, this distance, that is 2 kilometers. That is called it as the net resultant vector of that 8 and 6. If you go backward, that will be this vector, that is the 2. If you both go in forward direction, that will be 14. Okay, that means adding and subtracting vector in one direction or anti-parallel direction will be simple, right? But your vectors are not in exactly x and y direction, or it is not exactly same direction or opposite direction. They can stay in all 4 quadrants in your coordinate system, right? So now we're going to learn how to use the graphical method to add any number of vectors in any directions, right? We'll say I have a vector v1 and vector v2, and I need to add these two by using graphical method. Sometimes people call it as tail to head method, tail to tip method. Okay, so now only thing you need to understand, you're going to start with your first vector or the second vector. It doesn't matter which vector you're going to start with. Only thing matter is you follow the rules. So you have tail to head method. That means if I start with first vector, If I'm planning to use the centimeter ruler, then I need to measure V1, whichever length is, measure the V1 length to the right and make an arrow at the end. First vector is done, and then take the ruler and measure this angle. I don't know what angle is that in this case. We'll say some degrees angle. Then you take the protractor and measure that angle and take the length V2 and draw your second vector. First vector, ending of first vector, combine to the second vector ending in here, right? Tail and head. Follow that tail to head method. After you complete all the original vectors, you're going to label where you start, where you end, and then you're going to make a line from initial to final with the arrow head at final position. That will be your resultant vector. Then you're going to take the ruler and measure the length. That will give you the magnitude, and measure the direction with respect to your axis. That will give you the direction of the vector. Any vector quantity, you need both of them in your answers on the problem solving. Okay, so that's important. Okay, so now adding vectors in graphical method, I'm going to do another example for you. We'll say I have a vector upward direction, we'll say 5 kilometers, right? And I need to add another vector, we'll say 8 kilometers with some angle, 30 degrees. Okay, so now I need to add these two vectors by using graphical method, right? What you're going to do, you're going to start with one vector, first one or second one, it doesn't matter. We'll say I'm going to start with the first vector. So then you take your ruler and draw a line upward direction 5 centimeters. You cannot draw 5 kilometers, but you can rescale into centimeters, 5 centimeters. And then you take the protractor and measure the angle 30 degrees from here and make a dot at 30 degrees. And then take the ruler, keep origin here and draw 8 centimeters on that direction. And then you are done with adding vectors. Now you need to resultant. To find the resultant, you mark your initial and mark your final and take the ruler and combine these two lines, connect these two lines with your arrowhead at final. And then you're going to measure the length by using ruler. And then you're going to measure the angle with respect to your x-axis. Then you can express your vector. Okay, so now this R value is not 5, not 8, but different number according to your measurement. That's the resultant vector of 5 and 8. Okay. Okay, so now in addition to that, your graphical method, some people use it as a parallelogram method. Parallelogram method is a graphical method, but drawing your vectors at single point in parallelogram. What that means is that the earlier example that I have, V1 and V2, you will be able to complete the parallelogram in here, right? That means this length and this length are equal, this length and this length are equal. That means instead drawing this vector on this end, I can draw that vector in this end. If I do all the vectors at the same point, then your diagonal vector that go through your original vectors, we'll call it as the resultant vector. This is what the resultant vector is. That is called it as parallelogram method. Okay, so it's very important that this answer is wrong because you are taking the other diagonal element. That is not the vector we need. We need the vector go through the both original vectors. That's the diagonal that we need. Okay. Okay, so now let's move into most important part. This is the adding of vectors by using component method. First thing is understanding components. Let's get rid of this theta angle first. So we'll say I have theta, not the 30 degrees, okay, unknown angle. So now I have a vector which is not in your x direction, not in y direction. They are not perpendicular or anything. There is a single vector in different directions, some direction. So now this vector, I will be able to project into my x coordinate. This is my x direction. So I can project this vector into x direction. That projection, we call it as the x component, right? So in addition to that, this vector, I will be able to project into y direction. This is my y direction. This vector, I can project into y direction, that is call it as y component. Project into x direction, call it as x component, y component. That means writing this vector as it is one way. Other way is this vector I will be able to project into x and project into y. So these both ways are useful when you try to understand this analytical method. Okay, so now it's important that my Vx in here is x component, Vy is y component of V vector. So now when you go to Vx, Vx is actually adjacent of this rectangle. That means hypotenuse times cosine of theta is the Vx and Vy is the V times hypotenuse times sine of theta will be y component if this angle is given. Okay, so that's how we're going to write the x and y component. It's very important that you check what is your adjacent is. That is, in this case, Vx, but not always. Adjacent will be sometime your Vy, depend on which angle is given. Okay, adjacent is the basically closer length to your angle. Okay, so now component can be positive and negative depend on which quadrant that you're going to work with, right? So let's say I have x and y coordinate system like this. So I have x coordinate and I have y direction, negative x direction and negative y direction, and this is where my origin is, right? So now vectors can stay on the first quadrant, second quadrant, third quadrant, or fourth quadrant, right? So now your vector will say it stay in your first quadrant. We'll say I have a vector in first quadrant. Okay, we'll say V1, vector V1 in first quadrant with the angle theta1 with positive x-axis, right? So now you need to identify the component of this vector. How do you write the component of this vector? You complete the parallelogram. That means I need to find this distance, that is my x component, and this distance is my y component. This is V1x and this is V1y. So now you're going to write V1x and V1y, both are positive direction, and V1x is adjacent. That means I can write it as hypotenuse times cosine of theta1 and hypotenuse sine of theta1. That will be, if your vector is in first quadrant, according to the given angle, you will be able to write that. Okay, so now let's say that I have a vector in second quadrant, somewhere here, and that is, I'm going to label it as V2. And now you're going to complete your parallelogram. That means this distance I need is V2y, and the distance I need in negative x direction, this is V2x, and we'll say I'm given the angle theta2 in here, right? So now we need to write V2x and V2y. So now only thing I know that in V2x direction, I have a negative because it is in negative direction. V2y is in positive direction. So now adjacent again is x direction. Because of that, that will be hypotenuse times cosine of theta2. Other one is sine of theta2. Okay, so now you can work with the third quadrant, you can work with the fourth quadrant, exactly same way. We'll say I have one vector in fourth quadrant as an example, fourth quadrant and V3, right? So now I need to find those distance as v3x and v3 and this distance as v3y. So now we know that v3x is still positive, but v3y is actually negative y direction, right? And we'll say, I will give you the angle this as theta 3. So now what is adjacent? Adjacent will be v3y. Because of that, this is v3 of cosine theta 3, and this is v3 sine theta 3. Okay, so now you can draw one in third quadrant. In that case, both will be negative. Okay. So now after you know how to write the component on each quadrant, that means you can do all the problems if you carefully handle those directions on your to your problem. Okay, so now addition of vectors. Now I told you I can write this vector in any direction to x direction projection and towards y direction projection. After I find the x direction projection and y direction projection, so I will be able to find the resultant of that vector. That is exactly what I had earlier. But we need this information sometime, because when we have more vectors, or I have two vectors in this way, I need to get my resultant vector in that case, right? So to do that, you know that you're going to complete the parallelogram. After you complete the parallelogram, this diagonal will be your resultant vector. How do you find this vector? That is what the Pythagorean theorem that you learn in your elementary school will be helpful you to find the magnitude of the vector. That means this vector I will be able to calculate by using your v equal using x component of its squared plus y component squared and take the root. That will give you the magnitude of the resultant vector magnitude. Okay, how do you find the direction? Any vector should have the direction. Then you're going to write tangent of theta is equal, in this case, opposite over adjacent, that will be vy over vx. And then you're going to find the theta by taking tangent inverse vy over vx, give you the direction. So now when I say this direction, this example, it is in first quadrant. If it is not in first quadrant, you need to write the direction with respect to positive x-axis as always. Positive x-axis. That's important. So now this is the Pythagorean theorem that we already know how to use. But it's very important that this theorem works when I have only two vectors. That two vectors are perpendicular to each other. Otherwise, this theorem not going to work. Then, if you have more vectors, more than two vectors, what you're going to do? I have many vectors in my diagram. What you have to do? So you need to carefully write down all the vectors towards your x component, towards your y component. Then you're going to get your final two vectors as x component and y component. And then you come to this theorem and use it to find the resultant vector. Okay, that's why the components that we learn is important. As always in your all physics classes, this is most important section. Okay, so now we'll say I'm going to do a simple example, not to finalize, but simple example. So I have mail carrier travel in north direction, right? In north direction and move 25 kilometers in north direction. Let's draw the cartoon first. So I have north direction 25. North direction 25 kilometers. Okay, and then she decided to travel in the direction 60 south of east. So south of east, that means 60 degrees from the east. That means you have east in somewhere here, and 60 degrees from that, decide to go 60 again kilometers, 60 kilometers, right? And then she decided to travel east direction 20. So that's a small one. So 20 to the east. So now you need to identify which quadrant these vectors are first. So first one is not in the quadrant, but it is exactly in positive y direction. This is exactly in positive x direction. Only second vector is not in x direction and y direction. That means I need to definitely complete the parallelogram and find my x and y component of this vector. Let's say I completed it. I need to find this distance and I need to find this distance. Okay. So now x component is, in this case, my adjacent, right? So that means this will be positive x direction, that I have 60 length, 60 times cosine of 60 will be my x value of this. Cosine of 60 will be half, right? That means this will be around 30 kilometers, right? And then this length will be 60 times sine of 60, but it is a negative value because negative y direction. This number will be 30, negative 30 and root 3, because sine of 60 will be root 3 divided by 2, then it will be 30 root 3, right? So after you write your x component and y component from all vectors, you going to draw your cartoon of your resultant vector. That means I have all the components in x direction, but y direction, according to my diagram, 25 upward and 30 root 3 downward. That means definitely I have a small vector in this direction. Okay, so that will be around, I'm going to write ry, right? So now you're going to complete your parallelogram. Your resultant vector will be the diagonal element that we just going to find it out. This is what the resultant vector is. And let's write down this angle as theta. Okay. So now we're going to write Rx and Ry first. What is my Rx is? Rx is coming from second vector and third vector. Second vector I have 30 and third vector I have 20 in x direction. That will give me 50 kilometers. And then Ry I have x direction 25, but y direction I have negative 30 root 3. And how much is this vector? You're going to do the calculation and find it out. Okay, so this will give me a negative 26.9. Around kilometers. So now we're going to find the r by using the Pythagoras theorem. As we know, rx to the power 2 plus ry to the power 2 and take the root. And you're going to do it, and I get around 56.8 kilometers. So that's the magnitude of your vector. So now I need to find the direction. So now direction we will be able to write, as we know, tangent of theta is equal, in this case, ry over rx. And then plug those numbers into there and then find the theta angle that I get is around ry over rx. Let me do it actually. Ry is 26.9 divided by 50, 12, and half 10 of that. 28.2 around. So 28.2 decrease. So now this is the important thing that I mentioned. Give it with respect to positive x-axis. That means I need the angle this one. So that angle will be your direction with respect to x will be 360 minus 28.2. So that will be give you the angle that you need. Okay, so 360 minus 28.2. So I have my phone calculator will bothering me 28.2. Okay, so that will give me 331.8 around. I would say around 330. So that will be the angle of this all resultant. So this is how you're going to find your resultant vector of adding many vectors. Okay. Okay, so now we're going to move into the projectile motion, because projectile motion is the first part that we're going to learn by using these two-dimensional vectors. So now let's see kinematics equation. So everybody familiar with this kinematics equation already, and we did it for x direction and y direction separately so far. So now we're going to do them together to x direction and y direction. Why? Because if I drop this ball is keep moving downward direction. What we know, displacement is keep increasing in parabolic path, and your velocity is keep increasing linearly, but keep constant acceleration, that is negative y direction, 9.80 meter per squared second. So those things we know in vertical motion. So now when I project the ball, this ball will be projected with some velocity. Some people use naught, x naught, something, but I would like to use always v initial x. Instead, some people use 0 as naught. Okay. So now Vix, if I project this ball in Vix, this vector that I have as Vix, you see that it is exactly same size in x direction all the way until you complete your motion. This vector is stay the same amount length. That means that vector is the same. That means Vx is constant. So when I say it is constant, what that means? That means acceleration in x direction is 0. That's what it means. That means there is no acceleration towards x direction, right? Because you keep constant velocity to the x direction. But y direction, what will happen? We know it. Y direction is increasing linearly according to your velocity equation. It's linear relation of the velocities. So your velocity vector in y direction will keep increasing because it is keep increasing because of the acceleration 9.80 we have it in downward direction. So now in addition to that, if you take very small time interval, we'll say 1/60th of second, these two balls going to stay on the same level, and pre-pole object and the projectile object, they both are moving same amount of displacement at same time. They are staying on the same level, you see, in some seconds. So now we need to analyze this problem towards x direction and y direction. It is very simple if you understand what is the projectile motion do. Only thing you need to understand, in x direction there is no acceleration, y direction, negative y direction, there is acceleration. That is what the 9.80 value is. And then these three equations will be able to use very easily if you know initial and final velocities, informations, and displacements. Okay, so now let's go back to another problem, because your problem can be project horizontally as we do it on the experimental setup in your lab, and also that can do the project with some angles, and you can kick the ball from some height, you can project the ball from some height. There are many variation of the problems. right? So now in this case, this is where that our vector information important. So I have an initial velocity. Again, I'm going to use I. Initial velocity is not in x direction or y direction. That means I need to write my x direction and y direction velocity by using vi value. That we already know. If I know the vi value, that means x direction vix will be equal to vi velocity that I have it in here times cosine of theta naught, and viy is equal vi times sine of theta naught, right? That means that is your x velocity keep constant throughout the process. That is vi times cosine theta naught. Y velocity is keep decreasing at the top. Velocity is 0, then increasing in downward direction as your drop-in object, free fall motion, and throw-in object upward will be the same process. Okay. So now important thing is, let's analyze this little more. So now x direction, what I said, in x direction, your acceleration is 0. So now the three kinematics equation that we discussed, let's move into the first one. X final equal x initial plus v initial x direction time plus half acceleration x direction time square, right? So now what will happen to this equation if I use in x direction? So it's very important that you choose the origin, that coordinate system. You need to mark the origin in your system. Everything you are doing will be with respect to that origin. This is where the 0, 0 is. So now this arrow that I make it in here saying that I use this equation towards positive x direction. That's what it means, right? So now x final is where that going to land. This is the x final distance. We call it as the range. If it's complete your position, it land, that distance, we call it as the range. In other words, in here, that is the name, use it as range. Okay. So now this height, maximum height position, where the velocity y0, that position we call it as maximum height. Right. So we use those symbols for to represent the range and the h. You can use those symbols later, but now everything that we are working with x and y values, right? So now this equation I definitely can write into x direction. This one is 0, right? If I start from the origin, this also 0, right? Then your x final will be equal to v initial x and time. That will be your equation towards x direction. So now what will happen, your second equation, v final equal v initial plus x direction, acceleration, x direction, and time. So this part is again 0. So now it says initial velocity in x direction equal final velocity in x direction. We already know that. We don't even need to try with this equation in x direction. And your last equation also the same. Twice acceleration, x final minus x initial. So this also 0, x direction. That means this again give you your x directions velocities are the same. That also we already know. That means that equation is not needed either. So only equation useful in x direction will be my equation that I write in first time in here, right? If your initial starting point is origin, otherwise you have the v xi part into the equation. Okay, so now your equation will be just that for the x direction. Now we know the y direction. Y direction always our free fall motions equation will work, right? You need to carefully use the directions and carefully handle those equations. Now important thing is x direction and y direction, you have exactly the same time. They cannot have different time. This motion will take the same time, right? Both directions we have the same T notation, but other things will change accordingly. Okay, so now projectile motion has some important information. As I say, this is, we call it as the range, and this is, we call it as the maximum height. So it's very important that maximum height place, your bidirectional velocity will be 0. Because if I throw something up, this go top and then land back. This top place, there is no velocity y direction, it is velocity 0. But if it is a projectile, x direction velocity is still there, but only y direction velocity will be 0 at the top. Okay, and in addition to that, there are very important information in projectile motion. This is the simulation diagram that you can do the simulation by using Mathematica or MATLAB, and then you're going to get these curves. So there are some important information you see at this point. This point, 15 degrees and 75 degrees land on the same range position. And also, you see that here 60 and 30 degrees land on the same position. Those we call it as complementary angles. That means add up into 90 degrees. If you have two projectiles which start with the same velocity, different angles, if these two angles add up into 90 degrees, they're going to land in exactly the same place. Okay, so in addition to that, longer range you can reach at 45 degrees. If you need to throw the ball far away, 45 degrees is the best solution. Okay, if you need to go more height, then probably 90 degrees is the best solution. 75 is here, 90 go exactly on the vertical line. So these things are some kind of features that you can see it on the projectile motion. Okay. So in addition to that, we doing approximation by saying that it is there is no air resistance. We ignore the air resistance, but what the air resistance do actually slow down the motion. You see that in here I project ball in 60 degrees. This 2 is without air resistance. This is without air resistance. Okay, so now when I have air resistance, what happens is your ball do the path 1. That means range is lower and also height is lower. Okay, that is seems to be poor assumption. Okay, so let's do this question. It's very important that you do a couple of questions, work on the recitations questions many times, couple of times at least, and do this question and also do some question on your textbook. That's the only way that you can really understand those things that we are not able to go over all the questions in the class. Okay, so that is your part that you need to complete it in your head. So this will helpful for you to get an understanding how to start the questions and how to do the questions by using a correct way. So now I have a driver, motorcycle driver, speed horizontally. That information is important. And then this high clip and also leave the clip of the land, ground below 90 and calculate the initial velocity. Those are the informations given in the question. So now first thing is you need to definitely draw the diagram, because physics does not work unless you draw the cartoon by labeling your coordinate system. So now I have an object in here, motorcycle person and motorcycle, and that will going to travel with initial velocity x. That is what it's asking us to calculate, and this will be my ground level. This ball will be land into the ground, and this is where your ground is, right? So now as soon as you label those information, you need to start labeling your coordinate system. That means you can label it on the bottom if you want, you can label it on the top, or you can separate your problem into part by part, and according to that part you will be able to label anywhere you want. But whole question procedure that you're going to follow will be belong to this coordinate system. Because of that, It's you need to keep consistent with your own problem to solve it. So I'm going to label my coordinate system in here, but my experience, this is the easy way to label the coordinate system. Okay, X and Y direction. That means if I measure anything towards right direction is positive, leftward direction, negative, upward, positive, downward, negative. That's what it means. This is where my 0, 0 or the origin located in my problem. Right? And in addition to that, what we know, label the informations given to you. So VIX, I need to find it out. It is not given. But as soon as I see, since this is moving in horizontal direction, there is no Y directional velocity at the beginning, right? So in addition to that, I have X initial is 0 because I start at the origin. Y initial is 0 because I start at the origin. So now this is where my final is. At final position, V or X final is given, it is 90 meters positive value. And Y final is negative value because it is, my origin is on the top. Because of that, this is negative 50. Right. So in addition to that, since question is not asking about the final velocity, there is final velocity that if you need to calculate, but question does not ask it. Because of that, I would not write it. But both direction you have time t, and in addition to that, x direction acceleration always 0, y direction acceleration is negative 9.80 meter squared second. Those are the informations that we know, right? So now we know 3 kinematics equation. I'm going to write it for the Y kinematics equation. You already know those equations are useful in X direction also. Okay, let's write them for revision. AY and time is squared, and V final Y direction equal V initial Y direction plus acceleration y direction time, v final y squared equal v initial y squared plus twice acceleration y direction y final minus y initial. So I write it for y direction, and x direction only work in one equation, that will be x final equal x initial plus v initial and time. Since acceleration 0, your last term will be 0 for that. So those are the 4 equation will work, right? So now you need to decide according to given information which formula you use. So now using a decision, take time. So take your time and decide what to use and think about the process that you're going to do. Then your problem will be easier. Don't put the things randomly into random equation and then you have no end. So you just keep doing it, but you don't know what you are searching for. You don't know what to use, and then you're going to end up with the useless or wrong answer at the end. Take time to decide what to do. So now I need to find the V initial X in the formula. That means definitely V initial X I have only in this formula. This formula is useful, and also if I use this formula, that will be X final and X initial. We already know it is 0 in this problem because of that VIX and time. That means VIX will be able to calculate if I know the time. So let's keep that behind. We need it later. But by watching this, X final is given. Only thing I don't know is time to solve the VIX. Now I need to find the time. According to the given information, I have 3 formulas on the top. Which formula should I use to find the time? Right? So now this formula does not have the time, then I can cross it out. But second formula, I have time. Do I have y final velocity information? No, because of that, that also not useful. And first formula is useful to find the time, but be very careful. Sometimes if vy iy is not 0, this formula give you quadratic equation that will be hard for you to solve. In that case, go to one of these equation, and find something other parameter, go back to your first equation and plug the time or something, right? So you need to like make it simpler for you. Don't make it complex, then it's going to be a problem. So now we decide that this is the equation that we're going to use. As soon as you decide, you write the direction and write your formula in bottom. V final equal y final equal y initial plus v initial y time plus half acceleration y direction and time power 2. As soon as you write it, you know that if something is 0, make them 0 first. But don't plug the other values yet. So your y final equal half acceleration y direction and time to the power 2. Then my purpose is finding time here. That will be 2y final divided by acceleration in y direction. So then take a root. Time is a positive value. You can also see it. Y final is negative, ay is negative, numerator negative, denominator negative. Because of that, your time will be negative. Then you plug the values and you will be able to find t. So I have around 3.20 seconds if I plug the values. So that is the time. After you find the time, go back to here and calculate your v initial x. That will be x final is 90. And then I found the time 3.20 seconds. And this will give you the velocity around 28.2 meters per second. So that will be your final answer for the velocity. Okay, that's how you're going to solve the problem. Sometimes your problem will be 2 parts. You need to do this procedure for the first part and second part separately, right? Sometimes you can use whole motion. So it is you have to decide how to do the problem according to the problem. That's the important part that you need to understand in this process. I would again recommend you find some question on the textbook other than the question you have it on the recitation. If you need more questions, please reach out. I can provide many questions. Okay, so if you have any problems or concerns about how to solve the problems, it is always reach out, talk to me during the office hours. Okay, so that will be the end of this section.